In this video, we are going to learn how to find the roots of a complex number. So say we have z, a complex number, which is equal to r times e to the I theta. Now if we take the power of it, so z to the n, that will be r times e to the I theta to the power of n. And we can write it up as r to the n times e to the I theta to the n, and that is r to the n times e to the I times n theta. And we can write it also in the form r to the n times cosine n theta plus I sine n theta. And this is known as the Moira Theorem. Now say z is equal to some p times e to the I phi, then the nth root of z is equal to p to the 1 over n times e to the I phi over n. Now say z is equal to 1. It is a complex number because we can write it up also as 1 plus 0i. And if we draw it up, we have our imaginary axis and the real axis. This is 1, so this is our z. We can see it is straightforward that the magnitude of z, or just r, is 1. And then the angle between the real axis and our z is 0. So theta is 0 plus 2 pi k, where k is some integer. Now we can write up our z as r, which is 1 times e to the I theta, which is 2 pi k. Now say that z is some w to the power of 5. And we need to find w. So we can write up that w to the 5 is e to the I 2 pi k. Therefore w will be e to the I times 2 pi k divided by our n, which is 5 in this case. And now we need to look for our complex roots. So we're going to scroll down, we'll write up w again. W is e to the I 2 pi k over 5. Now, when k is equal 1, we have w1 equal to e to the I 2 pi over 5. Then for k equals 2, we're going to write those up. Then 3, 4, 5. So w2 will be e to the I times 2 pi times 2 over 5. And that is e to the I 4 pi over 5. Then our w3 is e to the I 2 pi times 3 over 5, and that is e to the I 6 pi over 5, and so on. So we have W4 is e to the I 2 pi times 4 over 5, that's e to the I 8 pi over 5, and we have W5 equals e to the I 2 pi times 5, over 5, which is just e to the I 2 pi, and that is 1. Now we should stop at 5, but we're going to try out also for k equals 6 and see what we get. So W6 is e to the I 2 pi times 6 over 5, and that is e to the I 12 pi over 5. Now we can reduce that to e to the I 10 pi over 5 is 2 pi, and e the remaining 2 pi over 5. So e to the 2 pi I 2 pi, that is equal to 1. And therefore we're left with e to the I 2 pi over 5. And you can see that this is actually our first root. So W6 is equal to W1. Now if we draw our roots in the unit circle, we have W5 here as it's 1, and then our W1 is I to the 2 pi over 5, so this would be 2.5 pi over 5, so we're somewhere in here, that's W1. Then we have W2, which is 4 pi over 5, so that will be somewhere in here, W2. Then W3 is 6 pi over 5, this is 5 pi over 5, and 6 will be somewhere in here, W3. And then W4 is 8 pi over 5, which is somewhere in here, W4. Now if we connect our roots with the origin, and here, we should see that they're equally spaced over the unit circle. You can't really see it in this picture, but this angle should be the same everywhere, and so on, and that is equal to 2 pi over 5. And our W's are called the roots of unity. Thank you very much.